Okay, let us move further. So this is the diagram of a weir section, the entire weir section, and this is shared with you in the class notes also. This diagram is available in the books also, though I have regenerated it on the computer, but similar diagrams are available in the books also. So what are its various components? It is very clearly written over here that this particular trapezoidal section is the weir wall. So this is the cross section of the weir wall. So weir wall is running perpendicular to the screen. Okay, and on top of the weir wall, we have provided crest shutter. So this is the crest shutter, and you can see that weir wall is of more height than the crest shutter. That means most of the storage that is obtained in the upstream side, that is due to weir wall, and some storage can be increased further by installing the crest shutter. So these crest shutters can be removed also. So when you install these crest shutters, then the storage can be increased up to this level. So including the crest shutter, whatever is the maximum level of water that we can store on the upstream side of this weir section, that is called the pond level. Okay, so all of you know that weir wall is provided to stop the river water and to create a temporary storage on the upstream side and to raise the water level so that this water can be transferred or diverted into an off-taking canal. So from river to canal, the first level of diversion that is carried out with the help of diversion headworks, and in the diversion headworks, this weir is an important structure. Okay. So this weir wall's function is clear, and this is the crest shutter. Its function is also clear. We have to increase the storage to some extent. So we can design this entire structure for the pond level that is shown over here. Out of that, the total storage, some part is stored by the weir wall and some part is stored by the crest shutter. So crest shutters are the option to increase the water level up maximum up to this pond level, which is the design pond level. This function of both of these two is clear. So, but this weir wall cannot rest on the loose granular bed of the river. It has to be rested on a solid platform. So this is this gray shaded portion. This is a concrete floor. Okay. It is concrete floor, but it is impervious to the water also. That's why its more prominent name, or the more you can say the familiar name, is impervious floor. We don't call it as concrete floor only. We prefer to call it as impervious floor because its impermeability has the important. So it does not allow the water to move to the subsoil in this portion. So the entire river bed is pervious. So the water in the rivers keeps on seeping down from everywhere, infiltrating down. So, but in this particular portion, we have to prevent the infiltration of the water into the soil below. So that's why we need to provide the impervious floor. Of course, this impermeability is obtained by providing concrete. So this concrete floor provides us the impermeability, and that's why it is called impermeable or impervious floor. Along with this floor, if you see, we have these two lines. And what we have written over here is, it is upstream sheath pile and it is downstream sheath pile. So obviously this is the impervious floor. On the left hand side, we have the pondage, we have the storage. So this is the upstream side of the weir and this is the downstream side of the weir. So in this impervious floor, on the upstream end of the impervious floor, we have installed this upstream sheath pile. Here also we have installed a sheath pile because it is on the downstream side, so it is called the downstream sheath. What you are seeing is just a line over here, but it is mentioned that it is a sheet. So why it is a sheet? Because this sheet is running perpendicular to the screen. Okay. So what is its basic function? In the next slide, it will be more clear that how it is provided below this impervious floor. basically its function will be more clear in the next chapter, where we'll be discussing about the seepage theories. Uh, this These sheet piles actually reduce the uplift force on this flow. Okay? These sheet piles reduce the uplift force on these flows. So what is uplift force exactly? That will also be discussed there only. But for the time being, let us understand that the water that seeps from the bed on the upstream side, that not only goes vertically downward as percolation. In the previous semester, we have discussed the difference between infiltration, percolation, and seepage. So here, when the water from the storage goes into the soil, that is called infiltration. Thereafter, it moves under gravity vertically downward, that is called percolation. But what you see is on the left hand side of this weir wall, we have this much depth of water from this floor level to the pond level. So this much depth of water is available. But on the right hand side, as of now, there is no water. But if more water will be coming, after that, this pond level, the water level will cross this pond level, design pond level, and it will go above that, and some overflow from above this weir wall and shutter, that will be observed. In that case, you will have the flow in the downstream direction also. But definitely there is a difference between water levels on upstream as well as on the downstream side of this weir wall. Okay, so in this particular situation, when there is no overflow, so water is stored up to the top of this crest shutter, and it is maintained up to this pond level, and there is no water on the downstream side. So larger the water depth, more will be the pressure exerted on the bed of this floor, on this block protection launching apron, and here the river bed also. So more pressure will be exerted on the river bed. So that pressure will inject the water into the pore structure of the soil. So that pressure will be initiating the infiltration. And that infiltrated water will not only go vertically downward under gravity, but it will have the tendency to move from underside of the structure and come out to the downstream side of the flow. Why? Because there is difference in the water levels on both the sides, so there is difference in the pressure heads. So while after entering into the pore structure, that means after the infiltration, the infiltrated water will have the tendency to move from this high pressure area to this low pressure area, that is zero pressure over here. So high pressure to low pressure, the movement of water inside the soil's pore structure, that is called seepage. Okay, so that seeping water, here the pressure is very high, and at the downstream end the pressure is zero, and in between everywhere the pressure will be reducing from a high value to a zero value. So in between it will be a non-zero value. In between, the water will be at a pressure which is non-zero, but it will be less than the initial pressure, but it will definitely be more than zero. So whatever pressure is there at any point, so that pressure is exerted equally in all the direction. So in the vertical direction, it will try to lift this structure upward. That's why it is called uplift pressure. Okay. So this much explanation of uplift pressure is sufficient as of now. So that uplift pressure tries to lift this floor up. So this floor has to resist the uplift pressure by its own weight if it is a gravity weir, or we have to provide the reinforcement also here, so that the uplift pressure can be resisted by the cantilever action of this beam, of this floor slab. Okay. So these sheet piles increase the passage of the seeping water, increase the length of the passage of the seeping water, thereby reducing the uplift pressure that acts on this flow. So these upstream and downstream sheet piles, on one hand, they reduce the uplift pressure, but there is another function also. When the river bed on upstream as well as on the downstream side goes down because of this covering action of water during floods, So going down of the riverbed may cause hanging up of these structures in the air, in the middle of the air, so they cannot hang on in the air, so they will be definitely settling down. Okay, so this is a flexible portion. So settling of this portion will not endanger the weir wall itself, but this portion is a rigid one. If the soil is removed from the underside, let us assume there is no sheet pile as of now. Okay, if sheet pile is not provided, then the bed level will go down in this area, and it will remove the sediment or the soil from underside of this bed also. So this much portion of the floor will be hanging in the air, and it will be cracking down. It will be trying to deflect down, so cracks may appear on the floor. So any crack on the hydraulic structure, that means failure of the hydraulic structure. So we need to prevent this type of failure. So scouring, the damage due to scouring is also prevented by installing these sheet piles. Okay, so sheet piles, they have dual function to reduce the uplift pressure on the floor, on this floor, and to reduce the damage due to scouring. Okay, so all these components are clear as of now. Remaining components are on the upstream side, we have block protection and launching apron. On the downstream side, we have an arrangement similar to that of block protection, but it is called inverted filter and followed by the launching apron again. Okay, so these block protection and the inverted filters, they are apparently same, with the difference that here you are seeing no gap between these blocks and the bottom layer. Here you are seeing some gaps between them. Is the only difference. But in general, when we are going to provide it, we are going to provide it this bottom layer in the form of gravel bed, and on the top of it, closely spaced concrete blocks. That means with no gap while stacking them. So no gap is left in between them, but they are not joined with the mortar. They are loosely placed only. So these are the blocks which are placed just adjacent to each other. But on the downstream side, similar blocks are placed with some gap in between. And here also, it is not the gravel bed only, it is the material in which the grading of the material is provided in the form of an inverted filter. So in a sand filter, if you want to filter the water and you want to create a sand filter, so what you do? In the bottom layers, you provide larger particles, or you can say the pebbles or the bajri type material. Thereafter, you provide the material of reducing size. So on the uh, top of it, you provide the coarse sand, and top of the all, you provide the fine sand. So when the water is poured into that filter, it will first enter the fine sand, it will move down the coarse sand, then further to the uh, larger particles or aggregates. So likewise, when the water moves from top to bottom in that filter, the pore structure, the pores of the material, they become wider and wider. So the permeability keeps on increasing. So water once entered into the filter material finds it more easy as it goes down, easy to flow as it goes down. But here in this particular structure, this portion is in the inverted form. That means as you move from bottom to top, the size of the particles keeps increasing. So the permeability increases from the bottom part of this layer to the top part of it. And in these gaps, we fill the bajri, or you can say the aggregate. Okay, those aggregates are put into these gaps so that these gaps are maintained also, and the water can come out easily from this portion. And why this inverted filter is provided? I told you that seeping water will try to ooze out from this downstream end, and we provide this safe passage for that water to come out. We don't want that this water should come out from here. We provide this passage here also immediately on the downstream side of the floor, so that water can easily come out from this portion and move to the downstream side. And now we are left with this launching apron. So how this launching apron functions Let us move on to the next slide that will make it more clear about this structure also, because we are going to see the same structure, the entire structure of the components of weir in 3-dimension diagram. So this is the 3-dimensional visualization of this structure. So what that previous this concrete floor or the impervious floor looks like is this. So this is the 3-dimensional visualization of the concrete floor or the impervious floor. So on the riverbed, first of all, we provide this type of a floor. Okay, so this floor is designed before actually providing it in the field. So the thickness, which is shown at various points in the varying thickness, that is in the middle it is more thicker, and on the downstream side of it, you see that the thickness is reducing. Further downstream, it is reducing further, and at the end and in the upstream side, we have these thicknesses. So why and how these thicknesses are provided, they will be calculating again in this seepage theories, the sequent lectures. But this floor is designed and it is provided on the riverbed. Above this concrete floor, we provide this weir wall. Okay, and on top of this weir wall, we provide the crest shutter. So this is the 3D visualization of how the structure would look like. Okay, so these are the sheet piles. Sheet piles are running. In the previous slide, you have seen in the form of lines only, and I told you that these sheet piles are running in perpendicular to the screen. So now it is very clear that why they are called as sheet piles, because they are in the form of sheet, and they are called piles because they are driven very deep into the riverbed. So they are not a single ordinary piles only; they are piles in the form of a sheet. So that's why it is called a sheet pile. So on the upstream side of the this impervious floor, this sheet pile, it is called upstream sheet pile, and which is provided on the downstream end of this concrete floor or the impervious floor, that is called the downstream sheet pile. So simple naming is there. Now on both of the sides, what you see is on the upstream side block protection, and on the downstream side inverted filter. So till now we have discussed the functions of every component till now. So we are left with this launching aprons. Okay, so launching apron on both of the sides. We have to discuss how it functions. So this is the pond level. Okay, up to top of this crest shutter, what you see is water is heading up to the top of this crest. Okay, so when water is heading up to this pond level, so there is no water flowing to the downstream side, or we can assume that very little water is coming from the upstream side, which is there at present in the river, and because the water is only heading up to this top of the pond level, we are diverting this water to the off-taking channels also. So we are not allowing any water to go to the downstream side. Okay, in that particular case, these launching aprons, they stay intact. So these two launching aprons, so now you are seeing in the red rectangular enclosure. So these launching aprons, they stay intact as we have provided. Okay, but what happens when flood comes? When more water is coming from the upstream side, and it is much more than what is diverted into the canals. If you divert the water into the canals, so some part of the flood water will be diverted, but the flood water is much more than the diversion capacity of the canals. So most of the water will be going to the downstream side. So how that water will be going to the downstream side and what will happen to this pond level? So now the water will not be maintained at this pond level, rather it will be overflowing over this structure, over this weir, over this crest shutter. And now this pond level has gone because water is not up to the pond level, and now the water level is called high flood level because it is the water level due to flood. And highest flood level, or HFL, is when we get the highest level of the discharge in the river for which we have designed this structure. Okay? So let us assume that highest flood discharge has come in that case, whatever will be the level of water on the upstream side, that will be called HFL on the upstream side. Okay. Similarly, this HFL on the downstream side will also be maintained during this high flood. When the flood will be there, so this water level will also be maintained, will be at its maximum level. So it will be called downstream HFL, or the highest flood level. So in this particular circumstance, when the water is coming on, a lot of water is coming from the upstream side and a lot of water is going to the downstream side also. In that case, this water will have a covering action on the riverbed. And what happens to this launching apron, because that riverbed will be going down. If on the both of these sides, if the riverbed is going down, that will endanger this structure also. That will endanger this structure also. So how this launching apron is going to protect us? See carefully these launching apron, what happens to it. So as the riverbed goes down, these launching aprons, because they are loose stones only, so they launch themselves in this slopy fashion, and now they are not called the launching apron, rather they are known as launched apron, because they have launched themselves in the desired position. So this is a stone pitching, you can say, the stone layer here, which protects the structure, which protects this particular soil in this area to get covered out because of the covering action of the flowing water. So this slopy portion of this stone, it provides protection to this entire structure. So the structure is not damaged. It protects the structure. When the flood wave passes and the normal flow conditions prevail again, so this will not come back. It will be there, but it will keep protecting. Now, when the normal conditions will prevail, this water level, this bed level may start building up again because of the deposition of the sediment that comes from the upstream side. But this launched apron will remain in the position of the launched apron only, and it will keep protecting. Because the river bed is loose, unconsolidated, and cohesionless material, so these loose stones can go further deeper also, and the exact layer may not be maintained in future also. So we keep on adding more and more stones over here, so that in case of the floods, the launching apron keeps its function on, and it keeps protecting the entire structure. So here we have one text line also, that after the river covers out the bed, the launching apron launches itself to provide a protective armor layer at the slope of 2 horizontal to 1 vertical, and is called launched apron. Okay, so the slope of this particular launched apron is 2 horizontal to 1 vertical. That means whatever is the depth up to which the riverbed has covered out. So twice that depth, this horizontal length will be there. So it will be sloping in the this slope, 2 horizontal to 1 vertical. So we have to design this launched apron or the launching apron so that in eventuality of the flood, it will launch itself into this slope. Okay, I think up to this point it is very clear to you. So here, let us discuss something more about the launching apron. So the scour protection provided for some components of hydraulic.